68, 95, 99, 7, you can memorize 34, 13.5, 2.35, and 0.15. And you can just add up those sections and you'll get the same answer that I get. And I'll show it to you both ways. So these are for people who just could not get it the other way. But it's still, one deviation is 68%, which means these two add up to 68%. These, which are two deviations in either direction, all of that should add up to 95%. And if I go 3 jumps and 3 jumps, that adds up to 99.7%. And then we took the last two little, and that gives me the little tails. So this is mainly for people who did not get the plain out 68, 95, 99, 7, which is totally fine. You just need to remember 34%, 13.5%, 2.35%, and 0.15%. And that's something that will not be given to you. It's something that you'll need to know. Now, I'm going to go away for just a second, but I'm going to come right back. On your formula sheet, I do have that the empirical rule is the distribution of a bell-shaped curve. 68% is 1 deviation on either side, 95 is 2 deviations, and 99.7 is 3 deviations. So you don't have to remember the numbers. That's on your formula sheet. But if you want to remember each little section, you will have to remember that. We good? Good. All right, we just did a problem. These are the steps of the problem that I did before. It says find the range, the standard deviation, and the variance using a calculator. So this is what we did on the previous page. We entered our data into L1. We did 1 var stats. Our max and our min is going to give us our range. Max minus min gives us our range. If we're doing standard deviation, Sx is our sample standard deviation. Sigma x is our population standard deviation. And how do we get variance? You square whichever answer you're looking at. And these are the steps to copy and paste. You hit vars, number 5. Number 5 was the number to get you to stats. Number 5 is for stats. And then you either choose one of those two. And then you hit the square button and then enter. So those are the steps of what we did before. So now we are ready to do some problems. So let me cover up. Let's see what we're finding on this one. We are finding the standard deviation and the variance. I want to find standard deviation and variance. Good. That's good. Then we're gonna do stat calc. Then we're gonna do 1-bar stats. We'll start off with that first. There's my stat edit. And then I'm gonna do stat calc, 1-bar stats. Now, all I'm asking for in this problem is the standard deviation and the variance. So before I have a choice of standard deviation, I need to know, is it a sample or is it a population? Sample. It is a sample. So because they told me that it is a sample, I'm going to choose that one. Then I go to my calculator, and I could do for this one, I could do 10 squared to get my variance. But just to practice, I'm going to do bars, go down to number 5, and I'm going to choose the sample standard deviation, which is 3. So the calculator is just sucking over this data, and then I'm going to square. So now I'm going to hit the square button, and then that's going to give me my variance. And again, the way that I got to that was I did bars, number 5, which is stats, and then I either chose number 3 if it's a sample standard deviation, or number 4 if it's a population standard deviation. All right, let's try one more. I want to know the same two things, the standard deviation and the variance. I'm going to do stat edit, stat calc, 1-bar stats. Because it is a population, what am I going to do for this one? The one with the O, the sigma. Okay, so I'm going to do OX or sigma X. What does sigma X equal in this problem? 5. So my sigma X equals 5. And then when I square that, this is nothing more than taking your sigma X and squaring it. So 5 squared is going to give me 25. Feeling confident? Let's roll on. Here is a word problem. Find the range, the sample variance, and the sample standard deviation. The range, the sample variance, and the sample standard deviation. All of those numbers have decimals, so it's 34.0, 33.2, 37.0, 29.4, 23.6, and 25.9. Myers did not come in. Travis is here, and Josh is here. Did everybody on this have sign the sign-in sheet? I think y'all did, didn't you? Y'all 3 did, didn't you? Mm-hmm. You'll pass it to Rachel and Travis, please. Stat edit, stat count, 1 var stats. And then when I do my 1 var stats, here's page 1. And scroll down, here's page 2. Alright, so technically I could say, what is the mean? I didn't, but we know the mean would be this one. Okay, this time I'm asking for the range. What do I need to know to get the range? Max and min. So it's going to be max minus min. So, oh, Jennifer, I did not type in my data. Stat, edit, 34, 33.2, 30. Where in the heck did that come from? 29.4, 23.6, 25.9, there we go. So let me drag that over, and then let me redo 1 var stats. That should look a little bit better. So we can get our mean, but this time we didn't ask for the mean, we asked for a range.
We're at 370.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try this one more again. Stat edit. Just 37. There we go. 3rd time's the charm. And stat count. Var stats. And then we're going to scroll down. A little bit smaller. Okay, so for our range, we need to know our high minus our low, or our max minus our min. So we can look at the numbers since there's not that many, or we can come over to page 2 of 1 var stats and do max minus min. 37 minus 23.6, that's going to give me my range. My next question was variance and standard deviation. They both want the sample, so which one am I going to be looking at? The SX. So I'm going to take the SX, let's say we want it to 2 decimal points. You know my math lab is going to tell you. So let's go to 2 decimal points. So it would be 5.13. There's that, there's that. And then to practice, we can do vars down to number 5, and we're going to pick number 3 this time because we're doing the sample, and then we're going to square it, and that is going to give me my last one, and to 2 decimal places it's going to be 26.35. Cool? Alright, now let's talk a minute about standard deviation. I want to know which one depicts a higher standard deviation. Which histogram depicts a higher standard deviation? I hear a B. Do I hear any A's?
A.
A. Tell me why A versus why B.
A is flatter,
Okay?
so the standard deviation would have to be larger in order to encompass the same area of the graph.
Good thought process. Standard deviation is how wide you spread. You got to spread wide to get an STD. Okay? So, we want to know widespread. how wide is this one spread? Spread. Not spread, but spread. How many points is this one spread from front to back? 20 points. How far is this one spread open? 45. Which one has the higher spread? B. The more you spread, the higher you are to get a STD. Okay? This one has a wider spread. That one has a 45 spread. This one has a 20 spread. So the higher the spread, the wider the data, the higher the standard deviation. It's wide open. The closer the data, the lower your chances of getting an STD are, because they're closer together. Lower the spread. Does that make sense? So for this one, B has more spread. You're only looking at the x-axis. We're not spreading it, we're spreading open. We're only looking at that x-axis. We're not looking at how tall it is, that's mode. We're looking at the spread, the x-axis. Now that we have mastered one set of data, we are now going to look at two sets of data. Ethan and Drew went on a 10-day fishing trip. The number of smallmouth bass caught and released by the two boys each day as follows. Find the population mean and range for the number of smallmouth bass caught per day by each fisherman. Do these values indicate any differences between the two fishermen's catch per day? Now, I will tell you when you're in your homework and you have two pieces of data, or two sets of data like this, you're not going to want to do the first one and then clear it out and then do the second one, because part B is going to ask you to go back to Ethan and then do Drew. And then part D is going to ask you to go to Ethan and then do Drew. So it's going to be a time waste for you to type it in and then clear it out. Then type in Drew, then clear it out, because part B is going to make you type in Ethan and clear it out. So here's how we deal with this. We call Ethan L1 and we call Drew L2. That way we have them both in there so that we don't have to keep pushing them in and out. So when I go to Stat Edit, I'm going to type Ethan in for L1, and I'm going to pay attention a little more as to how I type. And then I'm going to come over and type. You just hit the over button, the to the right button. So this is going to be my L1 and this is going to be my L2. And it doesn't matter how you put them in. I usually just put the first list in for L1 and the second list in for L2. So they want us to find the population mean and the range. That's all they want right now. So we have Ethan, which we called L1. And we have Drew, which we called L2. And we want to know the mean. We want to know, I'm going to go ahead and do standard deviation, and I'm going to do range. Now, because it's population, what do we call the mean? Because it's population, what do we call the mean? Who? Mu. You're right. Mu. What do we call the sample? The population standard deviation? What's our range going to be? Max minus min. And I could have told you to get the variance. I could have told you to get a lot of different stuff. But we're just going to do these three. So, when I go in to do one bar stats, we've got to do things a little bit differently because we have two sets of data, and I've got to tell the calculator which data am I looking at. Up until now, we've just had one set of data, so we looked at that one set of data. We have two sets of data. So, when I go to do stat calc, one bar stats. Now, you may have one of two types of calculators. If you have this type of calculator, you need to make sure, if we're looking at Ethan, you need to make sure that L1 is there. You also may have a calculator. So this is one type of calculator. The other type of calculator is going to just say one var stats. Okay, doesn't matter which one you have, you just need to be comfortable with both. If it looks like this, you've got to have L1. If it looks like this, L1 is understood to be there. So if nothing's there, it's automatically looking at the first list. So, when we look at Ethan, it's what we've always been doing. Enter, 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 do what you normally do. So I'm going to do my enter. And then I'm going to, there's that. And then I'm going to come down and I'm going to do second page. So this is my Ethan. This is my L1. Now, to do Drew, I go stat, calc, and I pick one var stats, but this time I have to change it to L2. If you look really closely, above the 1 it says L1, above the 2 it says L2. And they're written in blue or yellow or whatever your calculator has. Mine's in blue, so I hit the second button and then I hit the L2. So I'm going to hit second and then the 2, and that changes it to L2. That lets the calculator know that I want to know the mean, the median, and the mode, or what are the mean, the median, standard deviation, whatever. I want to know that of list 2. Now, if you have the other calculator, you would do one var stats and then just type in L2 behind it. But you've got to tell the calculator, I only want to look at Drew now. So now when I hit enter, 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 there is Drew's information, and I'm going to go ahead and scroll down to page 2. And here is second page of Drew's information. So this is all Drew. Okay? So my question says, what is the mean of both of them? 10. What is the standard deviation of the first one? 4.86. What is the standard deviation of the second one? 7.91. So, here's the mean of Ethan, here's the mean of Drew. This is going to be mu equals 10 and mu equals 10 because they were both populations. And then if I go to my standard deviation, it's going to be sigma x equals 4.86 and sigma x equals 7.91. Now, for my range is going to be high minus low. So my range is going to be, what is my high? 24 minus 5 is 19. And for this one, my range is going to be 20 minus 1, which is 19. Now, it says, do these values indicate? Now, they only wanted us to look at the mean and the range. The mean and the range. The mean was 10 and the range was 19. Does that tell us anything? So because they only wanted us to look at the mean and they only wanted us to look at the range, they says, does that indicate any differences? No, because they both have a mean of 10, and they both have a range of 19. Cool? Now, it says draw a dot plot. That was part B. Draw a dot plot. How do we draw on our calculator? Do you remember? We go to second Y. We go to second Y. Second Y. Remember going there last time? And then we hit enter. But if we draw it right now, are we drawing a dot plot? No, we're drawing a box and whisker. I mean, no, we're not. We're drawing a histogram. Well, if I draw a histogram, I'm just going to do zoom 9 to see what it looks like. Okay. If I did, and this one says a dot plot. Hold on. There it is. There it is. Hold on. My B. Go with C. If I look at this, this is a histogram. They wanted a dot plot, which means if I turn these into dots, dot, 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 dot. If I move this away, you now have a dot plot. So from what we've done before, what does this dot plot tell me? What kind of skewness does it have? Skewed right, because here's my outlier. Go with me? All right, find the population standard deviation. We did that. We did it up here. We found the population standard deviation. That was our sigma x, 4.9 and 7.9. And this question says, do the values represent a different story about the fisherman's catches? Which fisherman has a more consistent record? So, Ethan and Drew both caught an average of 10 fish. The distance between their lowest fish and their highest fish was 19. But their standard deviation, their spread, this one has a lower spread, this one has a higher spread. What does that mean? The higher the spread, the higher the STDs. So what does that mean about the numbers? Are they closer or are they far apart?
More spread out.
They're more spread out. So because this is higher, the numbers are more spread out. Because this is lower, the numbers are closer together. So who was more consistent?
Ethan.
This one was more consistent because that meant his weights were more close together. 4, 5, 3, 4, 6. His numbers were close together because his STD was small. These numbers were 4, 19, 2, 16. Their numbers were spread out, so his standard deviation was wide. Even though their range was the same, if I come back up here and look at Ethan's numbers. A lot of his numbers are 8, 9, 5, 8, 9, 5, 8, 9, 5. He's more consistently catching the same size fish. Drew has a 1 pounder and a 2 pounder and then a 15 pounder and an 8 pounder. He's all over the board. He's either catching a big daddy or he's catching a minnow. This Ethan is catching substantial ones every single time. So, for this problem, Ethan was more consistent because his STD was lower, which meant, the weights were